Welcome to Meet the STEM Professional, the podcast where we sit down, explore the journeys, challenges, and triumphs of experts across science, technology, engineering, and mathematics. I'm Sophie, and in each episode, we sit down with a STEM professional to uncover their experiences, insights, and advice for aspiring minds. Let's dive in. Today, we're talking to Hugo Thould, a geologist and energy expert. Hello, Hugo, and welcome to the Meet the STEM Professional podcast. Can you give us a little bit background information about yourself?
Hey, so nice to be here. Yes, so I studied earth sciences, went from there into BP as a geoscientist, so looking kind of exploring for oil and gas, moved from there into work in the industrial decarbonisation and energy development teams. Then left BP, joined a UK renewable developer, looking at new technologies and working out kind of what are the gaps in the market, the UK renewable market, mostly focusing on battery storage. And then left there and now kind of work in just general. Well, don't work actually, but just general.
Unemployed for the moment.
Exactly.
Between jobs. So, what exactly does earth sciences entail at university? What do you study?
Well, so earth sciences is basically it's a kind of hodgepodge of kind of looking at the Earth system. So that's climate, geology, geophysics, geochemistry, working out how we can apply science to understand it, and then use that to either and basically predict kind of future effects. So it's really useful in kind of meteorology, so looking at predicting the weather, but mostly on the kind of climate scale. So when you're looking in the present day, looking at climate change, that's all Earth sciences. So how do you apply science, so chemistry, physics, maths, to understand the kind of climate system and Earth system.
And did you study any of those kind of subjects at school, or how did you prepare for that kind of course at university?
No, it's quite hard to find. I wouldn't really recommending studying geology at school. So I studied physics, maths, chemistry, and history. And I saw as kind of, I was never really saw myself being a geologist, but I kind of came into it from loving science. I loved that kind of analytical approach. But I also liked history and seemed the perfect blend of the two, kind of like a general approach to science, taking kind of quantitative rules and applying them to quite a messy system.
And how did your university education help you prepare for your career spanning oil and gas and renewables?
So I think probably I say first thing, like any degree is never going to directly prepare you for your job, apart from some of the very much more vocational ones. What it really does do, especially earth sciences, gives you that kind of thinking like process and gives you the thinking framework to, you can go into you have the right kind of mental toolkit to go into a problem, analyze it, work out kind of what are the key variables and what's the kind of interconnections, and then apply that. So going from earth sciences into kind of oil and gas, it was a similar kind of thinking process. All you have to do is learn a bit more of the actual knowledge. So, okay, how does an oil reservoir work? That kind of thing. But it's still fundamental physical processes. So that was it. I think the nice thing about STEM is it provides you a thinking framework and an analytical framework, which you then apply to anything. And it's very much more about kind of problem solving rather than just kind of pure knowledge.
Fabulous. We've been talking about at school how analysing things is a key part of STEM. Did you have any memorable experiences with science at school that influenced your career path? So you said you did chemistry and physics. Is there anything from those subjects or mathematics that really kind of inspired you to go forward? Or was it just that mixture of history and sciences that kind of blended the geology into one?
I think probably I really liked, specifically on the kind of physics and chemistry, I just really liked how you could directly see that you read about something, you learn about it, you go, oh, that's really cool. And then suddenly you can directly then test that. It's that kind of creating hypotheses, testing hypotheses. And it's like a really instantaneous feedback to yourself rather than kind of, I feel like I love the history, the knowledge part of it, but it was very much kind of theoretical. And I really liked the kind of practical application of the kind of sciences. And then as to why I went up in geology, I think I was on a field trip and I was on a beach and someone's pointing out like, oh, that's a metamorphic rock, that's an igneous rock. And I was like, that's cool. The person.
That is pretty
endlessly. It turns out you're always invited back for walks, so recommend it.
Recommended. So what kind of inspired you then to move from, well, so you moved into BP. Why did you go to BP first of all?
So I said it's earth sciences kind of covers is very broad. It's basically, and I did an internship with BP more because it was the kind of accepted thing to do. Really liked the kind of mix of. So I was kind of split between either doing a PhD or going into industry, and I wasn't really quite sure what I wanted to do. And so I decided instead of like choosing a specific subject, I would go into kind of a broader thing. So I went into BP after an internship, and it was kind of the combination of, again, that kind of analytical framework, that kind of like academic approach, let's learn about something, then also again be able to test it. And it was being able to test it like, okay, what is this oil reservoir doing? Okay, let's go put $100 million on the ground and test it. And it was that kind of thought feedback loop, which I really liked. And then also, to be honest, energy is fascinating. It's connected with our entire world and the future. And I kind of wanted to kind of start getting involved in that. And it seemed a nice little transition from my degree.
And so would you recommend that people who are interested in this kind of field do an internship first, or would you say go straight in and apply for whatever job would be above a junior kind of consultant, or is the way in to do an internship?
I'd say it very much varies. I think internships are always really good just from a kind of testing out phase. I think that's the kind of good thing, especially with just approaching careers, to be honest. I think I'll probably do it differently if I was in the past. But it's just going in, saying, right, let's do this for 3 months. Let's find out if I like it. What are the kind of people? What is the kind of thought process? What's the day to day? Because there's always glorious job descriptions where you're like, oh, this is amazing. And then you get there and you're like, oh, this is very different. And having been on both sides of that, I think it's
And
definitely.
did you move around within BP and experience different sectors, or were you in the kind of on the field finding oil and gas and
Yes, I moved about quite a lot actually. So I started out, joined on a graduate program. So I started out in like grandiosely called exploration. So I was looking for oil in West Africa. Then moved up to looking more kind of how to get gas out of the ground in Egypt, and then how to decommission fields in the North Sea. I must say, while it sounds very exotic, working all over the world, these are always based in London. And then wanted to work more in the commercial side of things. So moved into BB we're starting up a new kind of green team. So moved into that, which is more kind of investment analysis. So looking at like what type of carbon neutral investments could BP playing in. So it's kind of like large scale hydrogen,
yeah.
CCS, how to decarbonize steel, that kind of stuff. So
And
quite a lot.
sorry, just to stop you for a second, and before I forget my question, you you just said about how it's all kind of worldwide and glamorous, but not glamorous because you're staying in London. Does that mean you're using particular kind of software or something to map the globe, or are you using models, or how are you working to find this oil and gas if you're not actually there, or who do you send in to do the drilling? And tell us more about that process.
So basically, the way it works, and kind of probably most science roles work, is you have a lot of data, and each data is different. Like it could be an Excel spreadsheet, it could be a very complicated program of like 2 terabytes, and you always need a program to assess that data. So that could be everything from Excel, kind of coding programs, or kind of specific platforms. We use something by Schlumberger called Petrel. You load everything up, you do your analysis, and you output a recommendation, which always comes down to an Excel model and a PowerPoint deck exclusively. So you kind of use every single software you can to work out the problem, and then you just go, right. And that's the nice thing, coming back to your earlier point of view about kind of analysis and like thinking. That's a good thing about STEM. It makes you very flexible, and you can say, right, okay, I understand the base, how this all kind of works. Therefore, I can do anything. I can apply it to anything, rather than kind of just going, right, I don't know how to work this. It's you understanding the causes behind things.
Yeah, that's very cool. And it's solving worldwide issues and problems, which is very, very interesting. So what kind of made you then pursue leaving BP and moving into renewables and battery storage, and why did you make that big change?
It's an interesting question. So I was working in the decarbonisation part of BP for about 1.5 years. It became kind of clear about 2 things. One, I'd done a lot of big scale stuff, like how do we do 10 gigawatts of wind or this. I never really actually kind of seen the in-depth, like how do we actually develop a project. Also, BP was pulling back from its kind of green agenda a bit. So those kind of 2 things came together. I was like, okay, let's work at A, let's get some like work at how you actually do one of these projects, because they're very complicated. And I think if you want to understand anything, you need to know how the top down works, like how the broader big picture, but you also need to understand how the bottom up. And it's being able to understand both of those. So I left and joined a kind of UK renewable developer looking at new technologies, mostly kind of solar and batteries, and also great opportunities to learn about the UK renewable market, which is changing rapidly and is incredibly fascinating.
That is very exciting. So why, or what would you say is up and coming within the renewable market in the UK at the moment?
So within the renewable market, so this, I'm sure some of you other guests will be able to answer this far better than me. But so throughout, since the grid was kind of created, we've had like large, like coal, gas, oil power stations, nuclear. They're kind of very big, massive ones which output a lot of stuff. And our entire grid has been based on that. Now we're moving to lots of smaller generators like solar, wind. You've got so many cool technologies coming out, but our infrastructure is not really designed to deal with these. So you've got a lot of people running around wanting to do really cool stuff, but the actual fundamental physical infrastructure isn't there to do it. And this is this kind of like key problem at the moment of like, yes, we now know most of the answers, like about how to kind of solve like climate change and kind of decarbonize our grid, but actually doing it and working out those little problems and how you actually deploy a solar farm, how you kind of build out a really high voltage cable, how you kind of balance for like day and night load shifting. So like you're generating it in the day, but you're not generating at night. How do you kind of balance out that profile? Those are all the kind of questions which are coming in. And each one needs new technology, new people. It's a great time to be.
Fantastic. So where do you think your career might lead you next? Where are you looking to explore?
Well, so having said I moved from the kind of big scale down to from the big scale top down to the small scale bottom up, realized actually I find the big scale top down a lot more interesting. So I want to go back into more kind of like systemic decarbonization. So how do different things interact? Because I think the way things interact is the most interesting bit, and that's kind of consistent from like earth sciences, geosciences, all kind of sciences, like what happens to things when two things collide. And that is the bit which I find really interesting. So kind of systemic decarbonization, how do you smooth the way and allow the public and private sectors to cooperate to deliver kind of a net zero UK and world? And that's kind of where I'd like to be.
Fantastic. So STEM obviously plays a huge role in your day-to-day life, and those STEM subjects that you have studied obviously prepared you to have the skills available ready to do these jobs. But I guess, are there any specific skills or lessons from STEM studies that have been invaluable to you whilst you've been working across the multiple sectors that you have?
I think probably yes, in terms of just the way of approaching a problem. Like in physics, for example, you can write an equation which describes that, and in chemistry you can do the same. You can do, and there's basically, I think, through science you learn there are like fundamental laws governing everything, and there are also bits where they don't govern or you just don't understand it. So knowing where you know something, where you fundamentally don't know something, and being comfortable with that distinction, and being able to like apply that kind of analytical framework to the bits you can find out about, and then being like, okay, right, I know enough now to be able to make a decision. This is like, I know enough to understand this bit I don't understand, but it's okay, it's not going to be impactful. That kind of like way of breaking down a problem into like pillars, and like, okay, this matters, this doesn't, is just, I think it comes from a very much a STEM approach of
Yeah.
like fundamental rules, there are fundamental laws. And this is a theory, this is a hypothesis, this has this much tolerance, this much uncertainty. That kind of appreciation of kind of fixed and floating variables all comes into like where you approach a problem and are able to solve things.
That's very interesting. Thank you. So, if students were interested in studying or moving forward into oil and gas or renewables, is there any kind of encouragement that you would give them, or any advice for studying at university?
Yes. In terms of university, I'd say start with earth sciences. I think it doesn't tag you down into any form of career. It's just incredible. There are probably about 30 people in my course. They've gone on to do everything from consulting to banking to energy to PhDs to academia, mostly in energy and climate change. So I'd say earth science is a great place to start. talk to people, work out what actually a role does. I'd say in terms of just a future, the world always needs energy, and we're going to need clean energy. We're going to need fundamentally clean energy if we're going to avoid kind of the impacts of climate change. And being part of that kind of massive transition from an entire economy, unprecedented levels of wealth in the world, to the same but in a clean way, it's a wholesale thing we've never seen before. And being part of that journey, I think just think is fascinating. And I think the best way to do that is, to be honest, be a scientist and be part of the kind of like investment, commercial, technical, and political solution that you need to kind of combat climate change.
Well, it is a real big problem that needs solving, and it needs solving fast. So is there any particular skills or mindsets that you would say that are important for success in this role?
I'd say kind of curiosity. Curiosity is wanting to kind of dig down and work out the root cause, because you always have kind of high level things. You observe something, and then there's always that kind of idea of like, okay, why is that? And kind of continue down until you reach that kind of root variable. So curiosity is really good. Mathematical, mathematical approach to things. It doesn't have to be, you don't have to do maths, but more being willing to see things as numbers, essentially, in some way, and basically being able to see that things are governed by laws, and then you can test those laws and you can try and understand them. So not being scared by anything just because you don't understand it, because fundamentally you don't understand anything. So you can be like, okay, cool, right, we can actually understand a little bit of it.
Life is for lifelong learning, isn't it? So it's all about continuing to push and continuing to expand your knowledge.
That's exciting.
So how do you think, well, the final kind of last little bit is talking about how your work impacts the world or your contributions to society. But we've kind of touched on that with how important it is to start being able to find these renewable energies and storing them in different ways. Have you got anything else to add to that, or?
No, I think say basically it's like a really interesting time. Like we're at the kind of pivot point of things, like pivot point of where would we start accelerating progress. Well, we should have done that a few years ago, but ignore that. It's really exciting to be involved. I think STEM is a perfect place to start. I think it gives you a way to look at the world and kind of learn about the world, and gives you enough flexibility to go, okay, I can work in any place. Like doing a STEM degree, doing STEM subjects opens up so many things, but closes nothing. Like you can always like learn about something else, but giving that like analytical framework and analytical mindset is just invaluable, I think.
And are there any particular words or any kind of wisdom you have for students who might want to study STEM subjects, or who are on the fence about whether STEM subjects are worth their time at school? And any inspiration you can give them that it might be valuable?
I'd just say yeah, just do it. Like I did maths, physics, chemistry, history at the equivalent of A level, and I was kind of trying to work out what I should do at university. I was doing 3 STEMs, and I realized that okay, I could always read about history, I can read about economics, I can read about geography, I can read about all these things, but to actually get to learn about kind of STEM subjects and all that kind of really in detail stuff, there's pretty much only one time you can really start doing that, and that's, I think, is at school. The other bits you can do a master's later, you can do a degree later, but that kind of base education is just really important, and I think STEM is just the best way to approach it. And it opens so many doors. Like it makes you so much more employable as well, to be honest, at the flat basis, to be honest.
Fantastic. Thank you very much. So thank you very much, Hugo, for your amazing advice and time. That brings us to an end of our episode of Meet the STEM Professional. We hope you found this inspirational and valuable insights from our guest today. Stay curious, keep exploring, and we'll see you next time.